Hello and welcome to Statistically Significant. In today's video, I will show how to perform a one-way analysis of variance using the RStudio software. So here today we are given a dataset on the life hours of bulbs produced in a factory in 4 different batches. We are to test whether there is significant difference in the mean life hours of the bulbs in the 4 different batches. First of all, why are we using one-way ANOVA here? Just see, our response, which is the life hours of the bulbs, is being affected by just one factor. The factor is the different batches. So as our response variable is being affected by just one factor, we are using the one-way analysis of variance model to test the difference of the means. So our null hypothesis here is that there is no difference in the mean life hours of the bulbs in the different batches against the alternative that yes, there is a significant difference in at least one of the pair of batches. So this is our data set here in a CSV file. The life hour, we are given 26 observations and 4 different batches. They are labeled as A, B, C, D. So A, B, C, D, the different levels of the factor batches we have, and we are now going to read this file into R. For this, we use the library function read R. Then we read the file. It's a CSV file, so we use the function read underscore CSV. Then give the file name, and yes, R has read this. Now just have a look. It's yes, and it's same as it was in the Excel CSV file. Now see, life hours, it's a numeric variable and R is reading it as a numeric variable, but the batches R is reading it as a character, as we have A, B, C and D here. But to apply the ANOVA test, we must make R read these batches as a factor. For this, we convert the batches into factors, and we do it using the as dot factor. Just a few fundamental things. We use the box plot to see, just have a visual of the difference of the means. And on the box plot we can see that yes, there is a difference of in the means of the 4 different batches, but we cannot conclude it from this box plot because the difference, because we have to test whether the difference is significant. Okay, difference is not actually what we want to see. We want to see whether the difference is significant out here. So now, one of the fundamental assumptions of ANOVA was that the data is selected from a normal population. So to test the normality of our sample, we use the QQnorm function. On our response variable, and then QQLine. Now just have a look at the graph, and we could see that yes, it's along the diagonal, the line and the variable, they are all around the diagonal, so our data is selected from a normally distributed population. So yes, we can apply ANOVA. Also, another assumption in ANOVA was that the variable in the different groups have equal variances, the principle of homogeneity. So to test the homogeneity of variance, we use the Bartlett.test function. But before that, we convert our batches which R is reading as a character into a factor. For this, we use as.factor, and yes, now they have been converted. You can see, hover the mouse over this. Now see, R is saying that the column 2 batches, it's a factor with 4 levels, A, B, C and D. So we have successfully converted the character into a factor. Now use the Bartlett.test to check the homogeneity of variances in the different batches. And if you could see that from the p-value that it is way more than our alpha value 0.05, so we can conclude that the life hours of the bulbs in the different batches, they do not differ with respect to their variances. That is, the principle of homogeneity of variance is there. The variance is homogeneous in the different batches. Now we come to the application, or how do we apply the ANOVA in R. For that, we name LFH live hours, and I use the AOV function Remember the linear model used in ANOVA. It's Yij equals to mu plus alpha I plus Eij. It's basically Yij is being regressed. Yij, the response variable, is being affected by the factor. So life hours is the response variable here, and the batches are the factors. Okay. Now while using the AOV, we have to specify the data from which we are doing our analysis. Now with the summary function on LFH to get the ANOVA table, and yes, we have got our ANOVA table. Let me just show you. You can see that the degrees of freedom, the sum of squares, the mean sum of squares, the F value, and the most important, the P value here. We knew that we have 4 different batches, so the DF is 4 minus 1, it's 3. We have totally 26 observations, so the total DF becomes n minus 1, which is 26 minus 1 is 25, and 25 minus 3 is the error degrees of freedom, which is the residuals here, 22. So now the P value suggests 0.123, which is way more than our alpha value 0.05, and thus we can conclude that there is no difference in the mean life hours of the bulb in the different batches from this sample data. That is, we accept our null, or we fail to reject our null. Okay, so this is how we do a one-way ANOVA test using the R software. You can also do a post-hoc analysis using the TukeyHSD function. And yes, we get our post-hoc analysis. It does a pairwise comparison of the treatment means, and you could see that the p-values obtained while comparing the different batches, they are all more than 0.05. That is, there is no significant difference in the mean life hours of the bulb in the different batches. As we have accepted our null, there was no need to perform a post-hoc Tukey test, but I just did to show you guys how to do it. Okay, so that's how we perform a one-way ANOVA in R. I hope you enjoy this video. Do like, share and subscribe. Thank you.